Okay, so here we have a variable squared minus a constant. Okay, so this is a case where you have to let x equal to secant. Okay, secant of theta. Now because of this 9 that's multiplied to it, we actually have to let it be 1 over 3 so that when I square this, it'll cancel out with that 9. Okay, so dx then is 1 over 3 secant of theta, tangent of theta d theta. Okay, so I'm not going to write these numbers yet because I'm going to be converting them all into theta afterwards. So for now, dx I'm going to replace with this. So I'm going to write 1 over 3 at the front. Write this 1 over 3. X to the power of 5, that's 1 over 3 to the power of 5, secant to the power of 5 theta. Okay, so if I square dx, right, if you square that, you get 1 over 9, right, secant square theta. Okay, so you can see why I chose 1 over 3 right there. That'll cancel out now, right? So this is same as times by 3 to the power of 5. Right, divide by 3. Okay, I can cancel out one of the secants already. So we have a tangent on top. Okay, we have secant to the power of 4 theta. And this is going to turn into tangent. So this is going to be a tangent square. So the square root of that will be just tangent. Like that. So now that will cancel out. Okay. Now 1 over secant is the same thing as cosine. Okay, secant is the reciprocal of cosine. So cosine theta to the power of 4 d theta. This is going to be 3 to the power of 4. Okay. Okay, so to integrate cosine to the power of 4, we actually have to use a double angle formula twice. Okay, so recall that the cosine of squared theta is equal to this. Half of 1 plus cosine of 2 theta. Okay, so if you square that, you get if I square this, square both sides, I get this. I get 1 over 4. So I'm going to square this binomial expansion. 1 plus 2 cosine of 2 theta plus another cosine squared 2 theta. Okay. Now, we have another square here. So for that, we're going to use the double angle formula one more time. So if this was replaced with 2 theta, this will become 4 theta. Okay. So this can be replaced with another half, 1 plus cosine of 4 theta. Okay. All right, let's expand this. Let me expand the inner bracket here first. Okay, so 1 over 4, you get 3 over 2 plus 2 cosine of 2 theta plus half of cosine of 4 theta. Okay, so I'm going to take that and replace with this. Okay. All right, let me zoom out. So we have 3 to the power of 4, which is 81, by the way. The 1 over 4 will multiply it to give you 81 over 4. And okay, now we're going to put that long thing into the integral. So 3 over 2. Okay, all I'm doing is copying and pasting. All right, now let's do antiderivative. So we get 3 over 2 theta. Okay, so it's going to be sine of 2 theta divided by 2. So 2 divided by 2 gives you 1. So I'm just going to leave it like that. It's going to be sine of 4 theta divided by a 4. So half divided by 4 is 1 over 8. Okay. Okay, now we have some values initially. Okay, so root 2 over 3 and 2 over 3. Okay, so from here, this actually means that the secant of theta is equal to 3x, which means cosine of theta equals 1 over 3x. Okay, so using this, root 2 over 3, and 2 over 3. So if you replace that with root 2 over 3, so 1 over 3, root 2 over 3, root 2, that cancels out, you get 1 over root 2. That is, for cosine, pi over 4. Okay, pi over 4. Now with 2 over 3, so 1 over 3 times 2 over 3, that gives you half, and cosine theta equals half at pi over 3. So pi over 3, right there. Pi over 3 and pi over 4 is what we have to plug in. Alright. So 3 over 2, pi over 3. Okay, so sine 2 times pi over 3. Sine 2 times pi over 3, 2 pi over 3. Okay, that's actually going to be equivalent to pi over 3. So this will actually give you root 3 over 2. So I hope you know your relative angles and special angles. Okay, and 1 over 8 sine of 4 pi over 3. 4 pi over 3. So 4 pi over 3, right? 4 pi over 3 is in the 4th quadrant. Okay, I'm sorry, it's in the 3rd quadrant. Okay, 3rd quadrant. So it's 180 plus 60, right? So this is going to give you minus, right, minus root 3 over 2. Okay, now we're going to plug in pi over 4. So it's 3 over 2 times by pi over 4. This is going to be pi over 2, so it's going to give you 1. Okay, so pi over 4 times by 4 is sine pi, which will give you 0. So that's much simpler. Alright, so let's simplify that. So 81 over 4, pi over 2, root 3 over 2, minus root 3 over 16. Okay, here we get a minus 3 pi over 8 minus 1. Okay. Okay, so let's not expand that. Let's just combine the like terms, right? So the common base there is 8. So it's 4 minus 3, that's pi over 8. Okay. And the common base here is 16. So 8 minus 1 is going to be 7 root 3. Right? 7 times root 3 and minus 1. Okay, let's leave it in that form.